Look out your window at the sun. Just feel that warmth on your face. In roughly 5 billion years, that exact same star is going to swell to a monstrous size.
It really is, like truly monstrous.
Right, and it'll turn blood red and physically swallow the inner planets of our solar system whole, like completely consume them.
Just devour them.
The ultimate giver of life is mathematically guaranteed to become our executioner. Welcome to the deep dive.
Glad to be here.
Today, we are taking some truly fascinating notes from a channel called Ziko's Space Stories. And our mission is to explore the inevitable, mathematically certain doomsday of our solar system.
Yeah, it's a heavy topic, but it's like just so fascinating.
It really is. I mean, you probably look at the sun and think of it as a permanent fixture, right? Like a constant.
Most people do, yeah.
But today, we are going to look at the cold, awe-inspiring, and honestly, scientifically grounded reality of how it all ends.
And to understand how a star dies,
Yeah.
you really have to understand the invisible war that is happening inside of it right this very second.
Right, a literal war.
Yeah, a war of fundamental forces.
Mm.
I mean, we look up and see a calm, glowing orb, but what you're actually witnessing is a really delicate, violent stalemate.
Astronomers call this phase the stable middle age of the star, right?
Yes, but stable is, well, it's a very relative term when you're dealing with a colossal nuclear furnace.
I always find that term funny, stable middle age.
Okay.
Yeah, it makes the sun sound like it's driving a minivan and paying off a mortgage or something.
Right, right.
But the reality of that stability is based on something called hydrostatic equilibrium. Let's unpack the mechanics of that for a second.
Sure. Think of it as the ultimate tug of war. On one side, you have gravity. The sun is incredibly massive, and all of that mass is constantly trying to collapse inward under its own crushing weight.
So gravity is just relentlessly pulling.
Exactly. Gravity never takes a break. It's always pulling everything toward the absolute center of the star.
So if it were just gravity, the sun would just crush itself into a tiny, dense ball.
Precisely. But there is a counterforce pushing outward. Deep within the core, the temperature and pressure are so intense that hydrogen atoms are just being forced to smash together to form helium.
And that's nuclear fusion.
That is nuclear
Yeah.
fusion. And this fusion process releases a staggering amount of energy. So you have gravity pulling everything inward and the explosive energy of like millions of nuclear bombs going off every second pushing outward.
Wow.
Right. And when those two forces are perfectly equal, the star holds its shape. That's hydrostatic equilibrium.
Okay, I'm picturing like a pressure cooker.
Oh, that's a good analogy.
Right. The heavy metal lid is gravity trying to keep everything contained, and the boiling steam inside is the fusion trying to blow the lid off.
Yes, exactly.
As long as the pressure release valve is perfectly tuned, the pot stays intact. But here's the mechanism that drives this entire doomsday scenario, that hydrogen fuel in the core is finite.
It doesn't last forever.
Right. The gas tank eventually runs dry.
And when it does, that delicate balance is broken. When the hydrogen in the core is depleted, it leaves behind this, an ash of helium.
Helium ash.
Yeah. And helium requires much higher temperatures to fuse than hydrogen does, temperatures the sun's core just doesn't have right now. So the fusion in the core simply stops.
And the outward pressure drops to zero.
Which means gravity instantly starts winning the tug of war. The core begins to violently collapse inward, just packing all that helium ash tighter and tighter together.
Now, this is the part where the physics felt incredibly counterintuitive to me when I was reviewing the notes.
Oh, I know exactly what you're going to ask.
If gravity's winning, right, and the core is shrinking, why does the outside of the star expand? Like, why does it puff up instead of just collapsing entirely?
It's a brilliant paradox. And it all comes down to the thermodynamics of compression. As gravity crushes that dead helium core, the sheer pressure generates an astronomical amount of new heat.
Huh.
Yeah, the core gets hotter than it ever was during its stable middle age.
Just from the friction of being squeezed.
Well, from the conversion of gravitational potential energy into thermal energy. It gets so unbelievably hot that it actually ignites a shell of unfused hydrogen that was sitting, just outside the dead core.
So it starts burning again.
Yes, this is called hydrogen shell burning. And because the core is now so much hotter, this shell of hydrogen burns far more ferociously than the core ever did.
Oh, I see. So it's not that the whole star is expanding all at once. The core is crushing down, getting superheated, and that heat basically acts like a blowtorch on the layers above it.
That's a great way to look at it. This new, really aggressive shell of burning hydrogen produces so much outward energy that it completely overwhelms the gravity holding the outer layers of the star in place.
Wow.
Yeah, the outer atmosphere of the sun is violently shoved outward, and as these layers expand into the vacuum of space, they cool down, shifting from a bright yellow to a deep, ominous red. And that's it. The sun transforms into a red giant.
And when we say giant, I mean we are not talking about a subtle increase in size.
Not at all.
The physical scale of this expansion is what makes this a literal doomsday. The sun is going to swell so far outward that it will physically engulf the inner solar system.
Mercury and Venus will be swallowed whole.
Entirely consumed.
Just gone.
Let me make sure I'm picturing the mechanics of this correctly, though, because they don't just instantly vanish, right?
Yeah, it's a process.
I'm trying to visualize a planet the size of Venus, with its thick atmosphere and solid rocky mantle, suddenly finding itself actually inside the outer layers of a star. Does it just, melt like an ice cube?
The destruction is actually far more agonizing than just a simple melting process. Long before Venus is totally engulfed, the immense tidal forces from the encroaching star will start to stretch and deform the planet.
Oh, wow.
Yeah, causing massive earthquakes and volcanic eruptions.
Because the gravitational pull on the side of Venus facing the sun is significantly stronger than the pull on the far side.
Exactly. And then comes the atmospheric stripping. As the planet is swallowed by the sun's outer plasma, the sheer friction of moving through that dense stellar material acts like orbital drag.
Like a spaceship hitting Earth's atmosphere too fast and burning up.
On a planetary scale, yeah. This drag slows Venus down, causing its orbit to rapidly decay. It begins to spiral inward toward the searing interior of the red giant.
That is terrifying.
It gets worse. The friction alone will tear the crust apart, and the intense heat will eventually vaporize the rock itself. Mercury and Venus won't just be burned. They will be structurally disassembled and absorbed into the plasma of our dying star.
They become a part of the executioner.
Yeah.
That is a heavy concept to sit with. So Mercury is gone, Venus is vaporized. Which brings us to the obvious question, right? What about us?
Earth.
Yeah, what is happening on Earth? Because Earth is sitting right on the edge of this expansion zone.
Well, the view from Earth during this phase will be a terrifying study in clinical physics. The sun won't just be a bright circle in the sky anymore. As it expands, it will begin to consume the entire visual field. Picture looking up and seeing a horizon-to-horizon wall of roiling red-hot plasma.
Oh, man.
Yeah. The concept of blue skies, of day and night, will be entirely erased.
And this is where the notes from Ziko's space stories get incredibly specific about the timeline of destruction. Because the Earth doesn't even need to be swallowed to be completely sterilized.
No, not at all.
The consequences are catastrophic long before the solar plasma physically reaches our orbit.
The proximity of the red giant will increase the ambient temperature of Earth's surface to thousands of degrees. We are talking about a fundamental shift in the state of matter on our planet.
Let's focus on the water first, because, we call this the blue oasis. The oceans are the lifeblood of the planet.
Of course.
Now, my initial thought when reading about the rising temperatures was that the oceans would just boil and create a massive permanent steam atmosphere, like a global sauna.
That's what a lot of people think, yeah.
But the physics dictate something much worse. Why doesn't the water just stay in the atmosphere as steam? If Earth's gravity hasn't changed, why does the water leave?
That is a crucial distinction, and it comes down to kinetic energy. When water boils, it turns into a gas, yes. But temperature is really just a measurement of how fast molecules are moving.
Okay.
At thousands of degrees, you're injecting so much thermal energy into those water molecules that they begin to move at staggering speeds.
They start vibrating and moving so fast that they hit escape velocity?
Precisely. They literally outrun Earth's gravitational pull. But there's a secondary mechanism at play here, too, called photolysis.
Photolysis.
Right. The intense solar radiation from the encroaching red giant will physically break the water molecules apart. The H2O bonds are shattered, separating into hydrogen and oxygen.
Oh, wow.
And hydrogen is the lightest element in the universe. Once freed, it immediately bleeds out into the vacuum of space.
So the oceans don't just dry up. They are dismantled at an atomic level and expelled into the void. The Pacific, the Atlantic, the deep sea trenches, all of it undergoes a violent global boil. And then the fundamental building blocks of that water are just deleted from the planet,
leaving the Earth entirely devoid of moisture, a bone-dry sphere.
And the hits just keep coming, because without the oceans, the atmosphere itself is next on the chopping block. The expansion of a red giant doesn't just output heat. It outputs a massive, violent solar wind.
Yeah, a dense stream of charged particles flowing out from the star at millions of miles an hour.
Millions.
Millions. Currently, Earth's magnetic field protects us from solar winds, acting like a deflector shield. But the sheer density and ferocity of the solar wind from a swelling red giant will completely overwhelm that magnetic shield.
It just bulldozes right through it.
It does. It will slam into our atmosphere and physically strip it away. The nitrogen, the oxygen, the carbon dioxide, all of it will be caught in the solar gale and blown out into deep space.
I want to pause and synthesize what that actually means for the surface of the planet.
Yeah.
Because without an atmosphere, there is no pressure. And with the ambient temperature sitting at several thousand degrees from a horizon-spanning star, I mean, the rock itself cannot maintain its solid state.
No, it can't. The silicate crust of the Earth will begin to soften and then melt completely. The continents, the mountain ranges, the ocean floors, everything will dissolve back into a churning sea of glowing magma.
It is a complete thermal sterilization. From the largest mammals to the deepest subterranean bacteria, every trace of biological history is incinerated.
Every last bit of it.
Earth ceases to be a planet in any recognizable sense. It reverts to a molten ball of rock, exactly as it was when it first formed 4.5 billion years ago. It's poetic, in a deeply terrifying way. We return to the magma we came from.
It is the inescapable cycle of stellar mechanics.
But the story doesn't end with a molten Earth and a monstrous red giant. Because as we trace this timeline forward, the red giant phase is not a permanent state, is it?
No, it's not. The sun cannot sustain that level of violent expansion forever. It's important to remember that the red giant phase is basically a death throw.
Right.
It is chaotic and highly unstable. Those outer layers of plasma that have swallowed the inner planets are now very far away from the sun's core.
Which means the gravitational grip holding them in place is getting weaker and weaker.
Exactly. The outward pressure of the hydrogen shell burning we talked about earlier eventually begins to occur in pulses.
Pulses.
Yeah, these thermal pulses are essentially massive cosmic hiccups. With each pulse, the outer layers of the star are pushed further and further out until finally the sun simply lets go.
It just exhales.
It exhales. The gravity can no longer hold on to the expanded envelope of gas and plasma, and it just drifts away into deep space.
And this creates a planetary nebula, which, despite the absolute horror we just described regarding Earth, is universally considered one of the most stunningly beautiful structures in the cosmos.
Oh, absolutely. It is a breathtaking visual. You have these expanding, glowing shells of ionized gas-vibrant reds, greens, and blues drifting outward for light years.
It's gorgeous.
And it is illuminated by the intense radiation still pouring out from the exposed core left behind in the center.
It is quite literally a glowing cosmic tombstone, like a beautiful marker signifying that a solar system used to be here.
That's exactly what it is.
But let's zoom in on that center. You said the core is exposed, all the outer layers are gone, the hydrogen shell is gone. What exactly is left behind?
What remains is called a white dwarf. It is the corpse of our star.
And the physics of a white dwarf are fascinating because they kind of break our intuition about how matter behaves. There is no more fusion happening, right? The engine is completely dead.
The fire is out. There is no burning hydrogen or helium. It is simply a dead ember glowing solely from residual leftover heat. But the gravity of this dead core is still immense.
See, I was trying to wrap my head around this. If there is no fusion pushing outward anymore, why doesn't gravity just crush this dead core down into a black hole? Like, what is stopping it from collapsing completely?
Well, that is where we enter the realm of quantum mechanics.
Oh, boy.
Yeah. When matter is compressed that tightly, the electrons surrounding the atomic nuclei are squeezed closer and closer together. But according to the Pauli exclusion principle, no two electrons can occupy the exact same quantum state.
They essentially refuse to be packed any tighter.
Exactly. They push back.
Yeah.
This resistance is called electron degeneracy pressure. It is not thermal pressure from a fire. It is a fundamental quantum barrier. That invisible quantum push is the only thing standing between the dead core and total collapse.
Okay, let me try an analogy here to see if I'm getting this.
Go for it.
It's like packing a suitcase. You put your clothes in, you push down, you zip it up. Gravity is you pushing down. Fusion was, I don't know, a bunch of inflated balloons inside the suitcase keeping it puffed up.
Okay, sure.
Now the balloons are popped, the fusion is gone, so you push down harder. But eventually you hit the clothes themselves. You cannot pack the fibers of the fabric any tighter without fundamentally breaking the fabric of reality. That resistance is the electron degeneracy pressure.
That is a brilliant way to visualize it. I love that. And because it is packed that tightly, the density of a white dwarf is almost incomprehensible.
The numbers in the notes are staggering. We are talking about taking roughly half the mass of our entire current sun and crushing it down into a sphere that is only about the size of the Earth.
The mass of a star, compressed into the volume of a rocky planet. The matter is so dense that a single teaspoon of a white dwarf brought to Earth would weigh several tons.
A teaspoon.
Yes, and because you have so much mass in such a tiny area, the gravitational pull near its surface would be hundreds of thousands of times stronger than Earth's.
So we have this dead, incredibly dense, glowing ember of quantum-locked matter, and that sets the stage for the final, truly haunting image of our deep dive. Because what happens to Earth? We established it wasn't swallowed, it was boiled, stripped of air, and melted. But it's still there.
It is still there. Over millions of years, as the red giant fades and the white dwarf is revealed, that molten ball of magma will slowly radiate its heat away into the freezing vacuum of space. The magma ocean will cool, solidify, and turn into a blackened, scorched sphere of rock.
A bird skeleton.
And because the white dwarf still retains a massive amount of the sun's original gravity, that burnt skeleton of Earth doesn't just float away, it remains tethered,
Locked in an eternal orbit.
orbiting a dead star.
Think about the sensory deprivation of that reality. I want you to really place yourself in that final state. For billions of years, Earth was a cacophony of life. The roaring oceans, the howling winds, the sheer vibrancy of the biosphere bathed in warm yellow light.
It's such a dynamic place.
Then the apocalyptic violence of the red giant, the deafening roar of boiling seas and stripping atmosphere.
And then absolute silence.
Just a scorched, airless rock, circling a tiny, fading white dot in the sky, circling in total darkness in the freezing cold of deep space. Forever.
The chilling finality of it is what makes the science so profound. There is no rebirth. The white dwarf will continue to radiate its leftover heat for trillions of years.
Rubium.
Trillions. Eventually, even that heat will fade. It'll stop glowing entirely, becoming a theoretical object known as a black dwarf, a cold, invisible lump of degenerate carbon and oxygen. And the blackened husk of Earth will just keep circling it in the pitch black of the void. A silent graveyard of worlds dictated entirely by the cold mechanics of gravity.
It is a graveyard, and it's heavy. We've just walked through the inescapable mathematical eradication of our home. But the ultimate takeaway from the science here, and this is what Ziko's space stories gets at so beautifully, is that this isn't science fiction.
No, not at all.
It is a locked-in trajectory based on the laws of physics.
It is a certainty. The universe operates on timelines that dwarf human comprehension, but those timelines are rigid.
And yet, when I sit with this information, I don't just feel dread. I actually feel a profound perspective shift regarding the present moment.
How so?
Well, we wake up, we look at the blue sky, we feel the rain, and we suffer from the illusion of permanence. We assume the stage we are standing on will always be here.
But the stage is temporary.
It is fleeting. Our beautiful cosmic oasis, this perfect balance of water and air and sunlight, is just a brief window in the grand timeline of the universe. It forces you to recognize the sheer improbability and luck of our existence right now.
We happen to exist during the golden age of our solar system, the window of hydrostatic equilibrium.
Exactly. We are the lucky ones who get to experience the sun as a life giver. But it also presents us with a massive existential challenge, because this terrifying sequence of events, the core collapse, the swelling plasma, the boiling oceans, it is locked in, yes. But it's billions of years away.
Roughly 5 billion years before the expansion truly threatens the inner planets.
5 billion years. Think about what humanity has achieved in just the last few centuries. We went from horse-drawn carriages to splitting the atom and walking on the moon in a cosmic blink of an eye.
It's true.
So I want to leave you with a final provocative thought. Since the physics of this doomsday are undeniable, and since we know exactly how and why our star will execute this planet, do you think humanity will find a way to escape?
It becomes the ultimate test of intelligence against entropy. If we know the ship is mathematically guaranteed to sink, do we have the capacity to build lifeboats?
What would an interstellar survival plan even look like, given a billion-year runway? Do we engineer generation ships to cross the void to a younger star?
Or do we manipulate the fabric of spacetime itself?
Right. Or do we transcend our biology entirely, uploading our consciousness into vessels that don't need water or air, vessels that can survive the cold, dark silence of the white dwarf era?
It is the final question of stellar evolution. Can the universe create a species smart enough to outrun the death of its own creator?
It is an incredible thing to ponder, something to keep in your mind the next time you open the blinds. Feel that warmth on your face and marvel at the beautifully violent temporary engine keeping us all alive. Thank you so much for joining us on this deep dive. Keep looking up, keep asking the big questions, and above all, keep exploring.